Welcome to today's webinar. The topic today is connections with circular hollow sections in RFEM 6. My name is Andreas Hörold. I am responsible for marketing and public relations in the Dlubal software company. For instance, the content of the website, German and English webinars, customer projects, newsletters, and so on. I will be the moderator today, and I will also present the webinar. I will be supported by my two colleagues, and they can introduce themselves.
Hi, my name is Walter Fröhlich. At Dlubal, I'm responsible for the customer support by email and phone. Furthermore, I'm a member in our development team for the add-on steel joints. Today, I will answer to your questions.
Hello, my name is Lucas. I work for Dlubal for 12 years now. I'm usually in the interface department, trying to develop things there. But I'm also in the customer support, active in the customer support, and today I will answer the questions together with Walter.
Okay, thank you for your introduction. Maybe an additional information, Walter and me, we are in the company for about 13 years. Okay, then we can switch off our webcams so that the attendees can see the full screen. I say some words, how you can ask questions, at least for the attendees who participate the first time. On the right side of your screen, you can see the control panel. You can show that with that arrow here, and then you can enter a question here. And yeah, my two colleagues will answer you. If you don't get an answer during the webinar because there are too many, for example, then you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Okay, then we come to the agenda today. At first, I will model a simple end plate connection that you can see on the right side. Then I continue with an hidden connection. Then an end plate connection with stiffeners. And I will utilize the auxiliary solid component. That's quite new. And I would like to show you how you can handle this component and what it is for. Okay, then I will start with the first connection. That's today's model. I will model all connections in that model. It's a steel frame with triangular truss girders, and those are all the members are circular hollow sections. Let's take a look at the results of the ultimate limit state. You can see the main internal forces are normal forces. We've got also My and Mz. But yeah, that doesn't matter for steel joints. You can consider all internal forces in such a connection or in all connections. Okay, then I switch off the results. I can click on or right click on the first node and I can create a new steel joints. The other way is to go to the navigator data and open types for steel joints and open with a right click the context menu and then new steel joints. Both ways are possible. First, I select the node, that node. Okay, so ultimate configuration, standard, members, next dialog. At least one member should be or must be supported. And we turn to the components and I add the first component, a plate to plate, this one. So member 1 and member 2. Okay, let's zoom a little bit in. It's at the moment it's rectangular, but we want to create a rounded plate, and we will do that in the next steps. So thickness of 10 millimeters is okay, but I will increase the size. Eighty on all sides. So, and the current dimensions are 400 by 400 millimeters. Because I will arrange the bolts in a round order, I will enter here 0. We do that with a later component. Okay, the weld, default setting is filled weld front side. That's okay. And I enter 5 millimeters. Okay, that's the first component. Now we want to cut the plate round. So that's why we use the plate editor. This one, plate editor. So plate to modify, plate to plate 1, plate 1, and with a rounding. So, and I only have to enter the radius. It's the half of the plate dimension, 200 millimeters. So this is this side. Now, that's all. So I copy that component for the other plate by right-click, copy component at the end. So, and I have to assign the plate number 2. Okay, that's all for the plate and the welds. And now we add the fasteners. Right at the bottom, you can see the fasteners. Okay. The fasteners should be on the plate. And plate to plate 1. And the other side, plate to plate 2. Okay. So I only change the diameter to M16. And I leave the strength grade as it is. And that's quite important. The pattern should be polar. So that looks already quite good, but we would like to assign not 4 bolts, but 8 bolts. So we move it a little bit to the outside. Sorry, that was a wrong click. So not 133, but 160. Okay, the angle between the bolts is calculated automatically. I deselect the shear plane and thread because the shear plane should be in the plates. Okay, that's all for this simple connection. Connection number 1. Then we create the next connection. Here left at the bottom, you can see create new joint. I have to assign the node. This one. You could also select more than one node. That's up to you. So that's Okay. Ultimate configuration, standard, members, okay. Components. Then we start with the first component, a cap plate. It's also quite new component. You can use it also for the top of the column. In our case, we used it for a horizontal beam. Okay. SwiftNet member should be member number 1. Okay. And I only have to create an actual displacement. I move it 100 millimeters in left direction. So then the weld, butt weld front side this time. Okay. It was created. So then plate editor, we would like to round that as well. Next component, plate editor. Yeah, we recognize the cap plate, but I would like to select rounding here and a diameter 120. Okay, and all corners. Oh, that looks already quite good. So then we do the same on the other side. That's why I select both components, do right click and copy components at the end. So then I have to assign the cap plate to member number 2. Okay. And create or assign also a weld. Butt weld front side. Okay. That's wrong. We doesn't want to rotate this. Why does that happen? I turn back to the cap plate number 1. Okay, that's wrong. Don't want any rotation here. So then I insert a member in the gap. That's why I insert component inserted member. So I open the library and you can insert all these members that are highlighted in blue. I select the cross-shaped section with that parameters 240, 115, next field, 230, 115, 10 and 10. Okay. So I have to modify the length, 100 millimeters, that's the gap. So, and the origin should be member 1. Okay. So now that's the half of the gap, and we fill the other side also with such an inserted member. That's why I copy that component at the end and assign it to the member number 2. Okay. So then I create a plate in the middle. Next component, plate, this one. So dimensions are 240 by 240. So I rotate it 90 degrees. Okay. And I move it 5 millimeters in left direction. Okay. Now we would like to round up the plate with the component plate editor. Plate to modify, plate 1. Rounding, the same procedure as before. And 120 millimeters on all sides. Okay, then we copy the last two components for the other side. Copy components at the end. Plate 2, the displacement should be minus 5 millimeters. Okay, that looks quite good. So, yeah, that's all. Now we do a member cut. Yeah, we would like to cut out this area here. So the rounding, let me check. Rounding plate 2. Okay, yeah. So now member cut. Left both the member cut. We would like to cut out the inserted member 1 by plate. Plate number 1. Yeah, you can see that now it was cut out. I could also define the welds, but I do that with another nice function or feature. With the multi-selection of the welds, I would like to create all welds with one step. You will see that later. Okay, I copy the member cut that we cut out this area here. So copy components at end, inserted member number 2 by plate 2. Okay, that's all. That looks quite good now. Now we create the welds, as I already mentioned, with a multi-selection. I insert component welds, sorry, that's this one. Yeah. Then member plate. And I select all these flanges and webs and so on. Okay. And the cap plate or welds here. Okay. So weld type is okay. Double filled weld. 5 millimeters. Okay. And you can see now all welds are created with one step. Okay. Then only the fasteners are missing. So I open the component library, fasteners. So plate 1. and plate 2. So I change only the diameter, and we would like to define 4 boards. Now, dimensions are okay, but I deselect the shear plane and thread. Okay, that's all. The hidden component or hidden connection is created. In the praxis, there's a thin sheet about this connection. That the connection is really hidden. So now we create the third connection. I copy. We use components from the first connection. I copy that. But modify the node. This node, I think, 102. Okay. But we modify it a little bit. The plate should be a little bit larger. 100. 4 times that we get dimensions of 440 by 440. So, okay. We also have to modify the rounding with the half of the diameter, radius 220 on both sides. 220. Okay. So we also have to modify the fasteners because we would like to add ribs here by 0 degree, and that would be wrong when I select or when I create the rib over the fastener. So that's why we changed the degree to 22.5 degrees. And also the radius, I move it a little bit to the outside. Okay, so now the rib doesn't crash with the board. So, okay, then we create such a rib with a plate. The dimensions should be 150 by 90. On member number 1. I move it 90 degrees. Okay, that looks already good, but we have to move it a little bit. So 85 and minus 160. Okay, now it is on the right position. Then we do plate cuts on this side and this side and this side. So I insert the plate cut. We would like to cut plate number 1 by plate and by plate to plate 1. So, and I also create a weld, a double-filled weld, 4 millimeters. Okay. We cut this side and created welds. We do the same for this side. Plate cut. Also plate number 1. This time by member, by this member here, member 1. So cutting method, this time surface. And a weld of double-filled weld, 4 millimeters. Okay, now the last plate cut on this side, on the upper side. So plate cut, plate number 1 with no, that was wrong. I must use the plate editor. Sorry. Plate editor, this one. Plate 1. Chamfer is okay. I have to enter the dimensions. 130 by 70. And only the corner number 4. Okay. So the first rib was created. Now we copy the 4 last components. Copy components at the end. And we need to modify only the plates. So the displacements and the rotations. 160 and 270 degrees. Yeah. We created this rib. And the same procedure as before. Copy the component at the end. And we need to move plate 3. Minus 160. 0, 0. Okay. This one. Now the opposite side. Copy the last 4 components at the end. Then plate 4. 160. 0 and 180 degrees. Okay. 4 ribs are created. And now I need to copy the last 16 components at the end. Let me check if I selected all. Okay, yeah. Copy components at the end. So then plate number 5, I have to change the parameters here. 113 minus 113 and 135 degrees. Okay, this one. Then number 6. 113 213, 235. That's not correct. Sorry, the typo. So, okay, that's correct. So then number 7. Minus 113. And 45 degrees. Okay, this one. So, and now the last plate on this side. Minus 113. 13. And 315. Okay. Now all ribs on this side are created, and yeah, we can copy them to the other side and modify them. Yeah, but yeah, we skipped that. That's quite boring for you. I open a new model where this already was created. So this is this one, and you can see also the ribs on the other side. In the near future, we will create a new, or we will modify a component that you can create the ribs on one side with one single component. I hope it will be released in the next weeks or month. I hope that. And yeah, you can see this. The last steps were very time consuming, and it will be easier in the future. Okay, we finished the third component, the third connection, and we continue with the last part of the webinar. That's already a prepared connection, and I would like to utilize the auxiliary solid component. Let me, I wouldn't like to display the auxiliary plane. Okay, that's why I deselect them. So, and I create an auxiliary solid because my target is I would like to cut out this plate with a rounding and also on this side. And that's why I will use the auxiliary solid. Let me create it. You can find it here at the bottom, auxiliary solid. And you can define box, cylinder, or section. I use a section. I open the library, and you can use all cross sections from the library. You can see those are all the components from the RFEM library. And I would like to use the massive half over. So with those dimensions, 75 is the height, and the width is 250 millimeters. Okay. So then the origin should be plate number 1. This is plate number 1. I have to rotate it 90 degrees. And you can also display the coordinate system of the auxiliary solid or of the component. So 270. And I have to move it in Y direction, minus 66. Okay. So, and now we would like to cut out all what the auxiliary plane contains. Okay. So that's why we enter plate cut. Plate number 1 by auxiliary solid. Okay, yeah, that's all. And when I undisplay the auxiliary solid, you can see, sorry, the plate was cut out. So we copy that components at the end for the other plate. Auxiliary solid 2 is for plate number 4. It's the opposite side. This side. Okay. And the plate cut should be also plate 4 by auxiliary solid 2. I undisplay the auxiliary solid, yeah, and you can see it was cut out correctly. Okay, yeah, you can use such auxiliary solid also on other places. For example, when you would like to create a hole in a web of an eye section, for example, when you have an intersection because of a pipe or something like that, or yeah, imagine you have got a damage. I would like to show you how you can also use such an auxiliary solid for a cylinder on this example. Cylinder with a diameter of 50 millimeters. So I rotate it 90 degrees. Okay, now you can see it already. And I could also move it a little bit. Example, minus 120 millimeters. Or also in Z-axis, 40 millimeters. Okay. So, and now we have to create a member cut to cut it out. So, member cut, member 1 by auxiliary solid, number 3. So I deselect auxiliary solid 3 and you can see the hole. Yeah, please note that the auxiliary solid must be long enough. Yeah. If you, well, let's try that. If we short that a little bit, then there wouldn't be any cut. Okay. You must define an intersection. So, okay. That was only an example. Yeah. Okay, that was the fourth connection, or the fourth point of the webinar. Let's take a look at the results. We could calculate all now, but on my computer it would take more than 5 minutes. That's why I open an already calculated model with all components. You can see the results in the table below. At the moment, there are no joint models. I can select the simplified joint model, where you can also see the colors of the design check ratio of the elements. But quite better to see this in the detailed joint model. Okay, oh, it's frozen. We have to wait a moment. Okay. Yeah, it's a quite large model with all the components and members and with the results. Okay, and now you can see the design ratios for the welds. On the lower side, you see the highest utilization of the welds. Well, let's take a look at another component. This component with the welds. This component. Okay, and you can see in the table the design ratio by design situation. We assigned the design situation number 1 to the steel joints design. We haven't gotten good overview. What is the maximum design check ratio? You can select also or display the table design ratios by loading with the results for the different combinations. I think the best is, it's my opinion, this design ratio by joint. You can see the different joints and the different design check ratios. You can, for example, double click on such a line, or you can select that button here or press that button, design check details. Then a new dialog will be opened. So you can see all the equations from the standard and also where you can find it in the standard. For example, for the fasteners. Okay, we can also watch at the weld. It's a plastic design of the weld. Also for the plates, you can, or we can press that button to see the results in the steel joints. You can also do that directly here, results in steel joint. So, and that's also a good button, consider specific component, and you will see only the results, what you click in the table. Here, for example, the ultimate limit state of the bolt or the bolt check, then the plate. Maybe I can move it a little bit. So for this one, so, and you can also watch at the equivalent stresses. You can print that in the printout report or directly. So bolts, bolt check, and plate check all is visible and can be printed in the printout report. Okay. Yeah. That should be all to the results. I turn back to my PowerPoint slides. I compared the 3 different connections, or the first 3 connections. I compared the load capacity for tension axial force. The highest maximum force is for the connection with the stiffness, then for the connection without the stiffness, and the weakest connection is the hidden connection. And you can also see the actual stiffnesses for compression, where is an infinite axial stiffness. That means that the stiffness of the connection is higher of the stiffness as the stiffness of the member. Okay. So, okay, that's all to this slide. Then we collected further information about the add-on steel connections. For example, the online manual. Let me click on it. It's the online manual. You can download the PowerPoint at the end of the webinar. I will show you on the website where you can find it. So then that's the link to the LinkedIn profile of our chief developer, Andres Work. You can find interesting posts here, for example, about the prying effect and the flange connection of circular hollow section. You can watch that video. He compared different connections with ring flange, then full end plate, and stiffened ring flange. That's also a direct link of his profile. If you are registered for LinkedIn, just follow him and you can see interesting posts. So then you can find a lot of models to download on our website. You can see the different easier connections or more complex connections. Just take a look at them. Okay. And the last link, you can see new features about the add-on steel joints. That's the newest component, the cap plate. I showed it in the webinar. Plate or auxiliary solid and so on, and you can find more information there. Okay, then if you want to get a free online product demonstration, for example, just contact our sales team with that link here, or you can scan that QR code. Or when you would like to get a non-binding offer for any of our add-ons or the program itself, just contact our sales team. So let me turn back to our website, dlubal.com, and under news and events, you can find the webinars. That's today's webinar, and that's the webinar of next week about masonry structures. Then the week after next week, optimization. Then in 3 weeks, Jürgen Teilmann and I will present this webinar or regularly webinar about the most frequently asked questions. Then the Python API, and so on and so on. Okay, that's today's webinar. In the next days, you will get an email with a direct link to that page, and then you will find the recording in the middle here. You can already find the presentation slides, and you can also find the connections here. I think it's the same file. We've got only different pictures, but when you download one model, there are all 4 connections included. Okay, that should be all from my side. I thank you for your attention. Thanks to my 2 colleagues for answering your questions. Yeah, I hope we meet each other in a future webinar. I wish all a nice rest of the day and bye-bye.